we're going to talk about today is getting started in service virtualization and more specifically getting started in service virtualization as it relates to performance testing. My name is Ray Solo. I'm with OpenText Software as a Service, and I'm a technical account manager. So let's go ahead and get started. The objectives of this webinar are to cover what is service virtualization, why you would want to use service virtualization, and how to get started with service virtualization. So what is service virtualization? I could have filled this screen up with a lot of technical jargon, but in the end, it's just a tool for emulating the behavior of a service for use in software testing. I like to think of it as the inverse of the OpenText ViewGen, where ViewGen is sending out requests. The service virtualization tool receives requests and replies to them. So why would you want to use service virtualization? And I could say that I was in performance testing for a lot of time before I ever touched service virtualization, and didn't really know that I needed it. And it's definitely possible to get by without it. But there are a lot of benefits to using service virtualization, and in testing certain type of applications, I feel it is indispensable. So some of the advantages of using service virtualization are faster time to market by speeding up release cycles. Basically, if you're building an application that's dependent on other services, if those services aren't ready, you can emulate them with service virtualization and continue developing without the need of everything moving along in parallel. Increase efficiencies by eliminating bottlenecks caused by application complexity. Service virtualization allows you to take a service that might be rather complex, that might not be ready or might be expensive to use, and replace it with something that is not expensive, that's easy to build. Shorter test and reproduction cycles, earlier detection of defects. This kind of touches on the first two. We can move faster with development because we're not dependent on other services that might not be ready or might be expensive. Improved overall product quality with fewer defects reaching production. There are several ways that you can achieve this with service virtualization, and when I look at some of the use cases, the slides below will touch on that. And reduce costs by eliminating the requirement for access to constrained business critical infrastructure, third-party systems, and pay-per-use cloud components for testing. And it's pretty obvious what that is, and I've touched on all of those in the previous bullets. So let's go ahead and talk about a real-world example. Service virtualization, the idea of it is pretty simple, but it might, especially if you've never used it or felt the need for it, it might be a struggle to understand why you would actually want to use it. In a previous career, I worked for a company that did automotive work and built automotive applications, and we built on a microservice platform. Most of the applications that we were building had 15 to 30 plus microservices that were also dependent on a lot of external services. One, especially in the automobile industry, one thing that is another service that's used a lot is bin lookups. So in the example that I have here, I am stepping away from any application that I've ever seen, and it's an application that I made up. But it's a website where a person goes in, enters their vehicle identification number and their zip code, and the application looks at your vehicle and where you're at, and it provides suggestions for maintenance. It alerts you like when you might need an oil change. This type of application would probably use a lot of external services, and that have costs and also limits on how frequently you can access them. For VIN number lookups, all of the major manufacturers have APIs where you go in and you submit a VIN, and it'll come back and tell you, the color of the paint, the type of engine, and all of that. So with this application, we're taking the VIN number, we're figuring out what model, what type of engine, looking at the service intervals, and then using the zip code to also go out and pull weather data for the, since their previous service, to see if there's been any extreme conditions, extra high temperatures or really low temperatures could reduce, the intervals for going in for an oil change. And with the zip code, we can also go out and find service locations that will do the work. If they need an oil change, we can use the API for various service, nationwide service industry, automobile service industries, and find a place that's near them, and offer them, you're due for an oil change. This place is just 3 miles from you. Can do it for this amount. So a whole lot of services, and it would be great to build this using a lot of microservices that go out and handle all of the different pieces of this, instead of having one service that looks up VINs. To simplify things, you could have a microservice that pulls the VIN information for Ford, one for Honda, one for Toyota, another microservice that goes out and connects to the Open Weather API and pulls historical weather data. So what we're looking at is a whole lot of separate services, a whole lot of internal microservices that are doing things, that are also reaching out to a lot of external services for VIN, weather, and maintenance options. The challenge with building this is, there are a lot of challenges that you can see right off the bat, but from experience, I know, the automobile manufacturers, they will limit you, to 10,000 requests a day. There's a charge for using a lot of them, especially pulling weather data. There's also a charge for pulling that. So, if you need to performance test this with 150 transactions per second for any length of time, it could get very expensive. So this is a great use case for OpenText Service Virtualization. We can replace, the Open Weather API. We can replace Ford, Toyota, Honda's VIN lookup API, and all of the others. And so that allows us to save money and not get in trouble or kicked off of some of these APIs for exceeding their use limits. Another thing that might not be as obvious, but it is vital to the developing microservices, is the ability to detach yourself, or if the microservice that's going out and pulling weather data is not ready yet, we can replace that with a virtualized service and allow all the other services to move forward without without having all of the services in a complete state. And one other thing that I really found valuable that I haven't seen a whole lot of discussion about in with service virtualization is the tool will allow the developers of the individual microservices to performance test and detach the performance of their service from the services that they're dependent on. One of the things that I noticed when performance testing a microservice that was talking to 3 other services was that as the other services were changed and their performance changed, the performance of the microservice that I was testing changed. Because it was dependent on these services, it was impossible to know, is the service that I'm testing getting worse, or one of these other 4 microservices that it's dependent on getting worse. So what we did was we broke out all of the different services and replaced everything with an API or with in service virtualization, so that when we tested the individual services, we knew that the results that we were getting were the performance of that service and not, the open weather being slow today, or the microservice just down the road, or that's being built in the next cubicle being slow for whatever reason. Yeah. So I think I hit on these on the previous screen. All of the external APIs charge per request. Throttling and internal APIs may not be ready. So I hit all of those. There's a couple more things I want to hit. So using OpenText Service Virtualization allows us to go past those things, and with internal APIs, are not tied to the another microservices development cycle. And the last benefit that I noticed that's also not commonly talked about is the ability to develop performance targets. Your performance tester and getting a target from the product manager or the product owner can be a challenge. And often they know it's like, all right, if I submit a request, drop my VIN in, my zip code, and submit a request, I want it to come back in 1,000 milliseconds or 600 milliseconds. But how fast does the open weather API need to be? How fast does that bin request need to be? What we can do is, in testing the application as a whole from end to end, is replace the service that we want to understand how fast that needs to be with service virtualization, and set it to no delay, where the response is instantaneous, just whatever the connection through the network takes, and then we can set it to 1,000 milliseconds or 10,000 milliseconds, and we can take that and look at that data and say, if we want an end-to-end response time for the entire site to be 1,000 milliseconds, then the open weather API needs to come back within 100 milliseconds or whatever. And you can do that, go through that process one by one, and determine the net impact of the performance of an individual microservice or request to an external API, of exactly how that impacts your final response time. Is it a one-to-one relationship? If open weather requests increases by 200 milliseconds, my end-to-end response time is going to increase by that, or is that not true? We found that extremely valuable, because what you'll find, especially when you're looking at 20 or 25 services, determining where to focus, your resources on improving the performance of the individual service. You don't want to waste time optimizing a service that has very minor effect. And that's what I've touched on there. Allows the development team to focus on a single microservice by removing performance impact of external calls, which gives you more consistent results because you're not dependent on performance of other services. And yeah, by adjusting that delay, you see how a single service impacts the total performance of the application. So the process for doing service virtualization is really straightforward. And if you've been in and used the OpenText tools before, whether Load Runner, UTI, or ALM, you'll pick it up very quickly. But you create a virtual service and you record the virtual service. Typically, you record the virtual service and then you run it. Very similar to performance, creating a performance testing script. I put together a demo. However, it does require me to adjust my my proxy settings, which would be an issue. So I'm not going to attempt that, and the problems that would cause for hosting this meeting. But there are a whole lot of great resources that I'll point you to at the end of this presentation that show you how to do that. There are a lot of, I'll talk about that when we get there. So service virtualization integrations. The service virtualization tool integrates with Load Runner Enterprise and Professional, UFT, ALM, and several others that you can find out about in the other in the resources that I linked to you below. But the key ones are Load Runner, UFT, and ALM. For performance testing, you can manage the service virtualization server from those tools, where the services that you have virtualized will spin up when you start your test, and you can manage it all from the Load Runner tools. You don't have to go out and have two windows open trying to juggle a lot of different things when you're running a performance test or functional test using service virtualization. Okay, and so here are the additional resources that I spoke about. There's a great video gallery, a whole bunch of videos on how to use the service virtualization. It is relatively simple to get started in using service virtualization, and right now you can start using service virtualization for free. The Service Virtualization Designer has a free version, just like Load Runner, where you can go download it and get started today. With the free version, there are limits on the performance, how many requests you can handle, but it's easy to get in and start scripting the services and seeing how that works. The link to the data sheet explains capabilities and what service virtualization does. The SV Help Center, the third link, is probably the best place to start. It is, all of these links are going to be in there, and a whole lot of other great information. And finally, there's Service Virtualization has a YouTube channel with a whole bunch of how-to videos that are really great, that can take you, from beginner to total expert in using service virtualization.